Morning, and we're looking today at chemical kinetics, beginning to run through the process. Definition of chemical kinetics is, there we go, the area of chemistry dealing with the speed of or rate of a chemical reaction. Now there are 1, 2, 3, 4 factors that control rate of reactions. They all deal with the amount of collisions that take place that allow it to increase how quickly the reaction generates. So the first is physical condition or phase. The smaller the particles involved, the more rapid they react. Second one is concentration. The more that's there, the more ability has to react. Third factor is temperature. The higher the temperature for most phases, but not all phases, the quicker the reaction will react. And finally, presence of catalysts. We'll talk about that later in more depth. All right, so there's two different ways we can look at reaction rates, either as an average reaction rate or an instantaneous reaction rate. Average reaction rate is defined as the change of the concentration of a substance over a specific length of time. So we give it a time, we compare the change that takes place inside of that. That compares to the change of concentration of a substance at a specific moment in the reaction. Now we're going to usually do average more than instantaneous, just because of the fact that's the way that it would work out more directly. All right, so here is an example of a rate of reaction with the average. We're going to do average rate of reaction here. So we're going to look at all these values independently. Let's scroll it up a little bit so you can see a little bit better. Copy all that down into your notes. All right, now we're only going to look at the first two factors here first. After that, we'll do the rest in class. All right, so let's compare the average rate of reaction from 0 to 50.0 seconds. So we're going to take 0.0905 molar minus 0.1000 molar, and we get a difference of 0.00905 molar. We're not going to worry about the negative. All that means is that it's disappearing. I'm going to take and divide that by 50.0 seconds minus 0.0 seconds. Gives us 50.0 seconds. Divide that through, we get 0.000190 molar, or 1.90 times 10 to the minus 4th molar per second. All right, now we'll do other values inside of there in class. The other thing we're looking at is applying stoichiometry to reaction rates. All right, so let's take a general form here. A to the A plus B to the B, you'll C to the C, D to the V. So when we look at a reaction rate, we're going to say that the negative 1 over A times the change in the concentration of A over the change of time, this is going to mean our reaction rate. The change in the concentration, brackets again mean concentration, over time, is equal to negative, and again, all negative means, negative here just means that it's disappearing, okay, is equal to 1 over C, the change in the concentration of C, the delta T is equal to 1 over D, the rate of reaction of the concentration of V. So here's look at the problem. Determine the rate of disappearance of ozone in the reaction of ozone to oxygen if the rate of appearance of oxygen is 6.0 times 10 to the minus 5th molar per second. I know that looked complicated, but it really isn't. Let's look at our reaction here. Ozone, which is O3, going to O2 oxygen. Balance it up, we get O2O3 yields 3O2. So if we use our equation, we're going to say that 1 over 2 times the reaction rate of ozone is equal to 1 over 3 times the reaction rate of oxygen. Now, again, that negative, all that means is it's disappearing, so we can basically get rid of it. All right, so we're trying to find the concentration of ozone, all right, the rate of reaction of ozone. So solving up, the rate of reaction of ozone is equal to 2/3 the rate of reaction of oxygen. All right, put a value in. Put a value in. So we have 2/3 of 6.0 times 10 to the minus 5th molar per second. That answer gives us 4.0 times 10 to the minus 5th molar per second. That's my answer. Here's another problem doing class. Determine the rate of appearance of carbon dioxide the reaction of carbon with oxygen if the rate of disappearance of oxygen is 3.45 times 10 to the minus fifth milli per second. That's it for notes. Hope that wasn't too bad. Take care. Be good.